Hello everyone, here's another further mechanics question from again June 2022 for Edexcel Further Mechanics 1, and this is question 6. So it says two blocks A and B of masses 2 kilograms and 4 kilograms respectively are attached to the ends of a light inextensible string. Initially, A is held on a fixed rough plane. The plane is inclined to the horizontal ground at an angle of theta where tan theta is 3/4. The string passes over a small smooth pulley, light pulley P, that is fixed at the top of the plane. The part of the string from A to P is parallel to the line of greatest slope of the plane. Block A is held on the plane with a distance of AP being greater than 3 meters. Block B hangs freely below P at a distance of 3 meters above the ground as shown in figure 4. The coefficient of friction between A and the plane is mu. The block A is released from rest with the string taut. By modeling the blocks as particles, find the potential energy lost by the whole system as a result of B falling 3 meters. Okay, so first of all, let's work out the total loss in gravitational potential energy. So let's write down the total loss in gravitational potential energy. Okay, now that's going to equal the loss in gravitational potential energy from B minus the gain in gravitational potential energy of A. So the total loss in gravitational potential energy is how much B has lost minus how much A has gained. And how much has B lost? It's traveled a distance of 3 when it hits the floor. So it's mgh. The mass is 4, g is g, and h is 3. Okay, that's fine. And then minus mgh again. Let's have a look at this. So what have we got? The gain in gravitational potential energy is going to be mass, which is going to be 2 times by g times by h. Now h is going to be 2. Let's just think about what that's going to be. It's going to be, we want the component that is going up the plane, so it's going to be 3 times by sine theta. Because if we visualize it, it's moved 3. So it's gone from there to there. And here is our angle theta. And this is the opposite that we want. So this is our gain in gravitational potential energy. So as it's moved, this hypotenuse is 3 meters. And in this triangle, these are corresponding angles. So that is also theta. So therefore it is 3 sine theta. So that is 3 sine theta. Okay, that's perfect. Now, what have we got here? We can, we're told that tan theta is equal to 3/4. So if we have our picture here, there's our theta. Opposite over adjacent is 3/4. So we've got a Pythagorean triple, 3, 4, 5. So therefore sine is going to be opposite over hypotenuse. So we're going to have 12g minus 2g times by 3 times by sine theta, and sine theta is going to be 3/5. Okay, well, we put that into our calculator. We find out that that is 82.32 joules to 3 significant figures. So that's our loss in gravitational potential energy. It's the loss in gravitational potential energy of B minus the gain in gravitational potential energy of A. Perfect. Now, let's think about the work done against friction. We know that work done against friction is equal to force times by the distance moved. And the distance moved is going to be 3 meters. And what is the force? Well, the force in this case is going to be the work done against friction. Friction is mu r. We don't at this stage yet know what mu is, but r we can find by resolving perpendicular to the plane. So when we resolve perpendicular to the plane, we get 2g cos theta. So that is going to be 2g cos theta times by 3. This is resolving perpendicular to the plane. And cos is going to be 4/5. So we're going to have mu times by 2 times by g times by 4/5 times by 3. Okay, so that turns out to be, when we work that out, 47.5 0.04 and mu. We'll leave it in terms of mu because we don't yet know what mu is. Joules, that's to 2 decimal places. Okay, so that's great. So that is our work done against friction. We're just building together all the various elements that we need in order to tackle this. So now we need to know our total gain in kinetic energy. So total gain in kinetic energy. Well, the system's released from rest. So the gain in kinetic energy for particle A, block A, should label them A and B, is going to be a half mv squared. So a half m. And we're told in the question that B hits the ground at 4.5 meters per second squared. So it's going to be a half times 2 times by 4.5 squared. The gain in kinetic energy for B is also going to be a half mv squared, which in this case is going to be a half plus 4, half times 4 times by 4.5 squared. So that's our total gain in kinetic energy. And when we work that, add those two together, that turns out to be 60.75 joules. Okay, so we're now in a position where we can begin to draw all of these different elements together, okay, using our work energy principle. Let's have a look and see. So let's bring these elements together now. So we know that the total loss of energy in the system, so total loss of energy is going to equal the work done against friction. So work done against friction. Okay, so total loss of energy equals work done against friction. So what's our total loss of energy then? So our total loss of energy is going to equal our loss in gravitational potential energy. So that was 82.32. And we're going to take away from that the gain in kinetic energy. So it's the loss of that energy, take away the gain in kinetic energy. So that is 0.75. So that's the energy that's been lost from the system. And that must equal the work that's been done against friction. So we've got 47.04 mu. And the only unknown in this equation, is mu. So we can work out that mu from this is going to equal, when we rearrange this, 719 divided by 1568. So therefore our mu is equal to 0.459 to 3 significant figures. Okay, and that is, actually I think I've done part A and part B there. Okay, so part A was find the potential energy lost. Okay, so loss in gravitational potential energy is there. That's our part A done. And this is the beginning of part B, where it says, given that the speed of B when it hits the ground is 4.5, use the work energy principle to find the value of mu. So this is the beginnings of part B. And then that's our final answer to part B. We found out what mu is. Okay, so far so good. Now, next part of the question coming up, part C. It says now, what does it say now? It says after B hits the ground, A continues to move up the plane, but it does not reach the pulley. Okay. Block A comes to instantaneous rest after having moved a total distance of 3 add D from its point of release. Okay. Ignoring air resistance, use the work energy principle to find the value of D. So B hits the floor, A slides up the plane, comes to rest a little bit further up the plane. The distance that it continues to move, in addition to what it's already moved, is D. So it already moved a distance of 3 meters, and then it moves a further distance of D before it comes to rest. Okay, that's going to be important in a moment. So first of all, let's look at the loss in kinetic energy of the particle A. So loss in kinetic energy of A is equal to a half times by the mass, which is 2, times by the speed, which is 4.5, or the velocity, 4.5 squared. Because that's how fast it was going when B hit the ground, and it moved up the plane until it came to rest. So that's our loss of kinetic energy, 20.25. Let's look at the gain in gravitational potential energy. So gain in gravitational potential energy. Well, we can see that it's moved a distance of d along there before it comes to rest, and that's going to be d times by sine theta will be how much it's moved up perpendicular to, well, moved up vertically. So that is going to be mgh. So that is going to be 2 times by 9.8 times by d times by sine theta. And that is 2 times by 9.8 times by d times by, and sine theta is going to be 3/5. Okay, perfect. So we don't know what d is at the moment, but that is 11.76 d joules. We're trying to work out what d is, so we don't know it at the moment. Okay, let's work out our work done against friction. So work done against friction is going to equal the friction force times the distance traveled. The frictional force is mu r, the distance traveled is d. We do now know that mu is 719 over 1568 from before, and the distance traveled is going to be, let's have a think about the distance that is going to be traveled. Let's just think about that. Work done is equal to force times the distance traveled. Well, the distance traveled is just d, and our r is our 2g cos theta. So r is 2g cos theta times by d. Because remember, for r, we needed to resolve perpendicular to the plane. So that was 2g cos theta is where our r came from earlier in the question. And we know that cos theta is equal to 4/5. So we can put all of that in, and that gives us, just right there, that's 4/5. We sub all of that in, and we find out that that is 7.19 d joules. Okay, so we're gathering together all the elements that we need now. So the total loss in energy is equal to the work done against friction. So we can draw these elements together now. So total loss in energy is equal to work done against friction, work done against friction. Okay, let's have a look at that. So the total loss in energy is the loss in kinetic energy, which is 20.25, minus the gain in gravitational potential energy, which is 11.76. And that must equal the work done against friction, which we've just established was 7.19 d. The only unknown in that whole expression is d. So we're going to add this over to the other side and then divide by what we get. And when we do that, we find out that we get that 20.25 is equal to 18.95 d. So therefore d is equal to 1.07 meters. And that is that question finished. I hope that you found that useful, and I will see you in the next video.